Now we're going to talk about merge sort and quicksort in C++. Now, before we start coding, let's understand the concepts of merge sort and quicksort. Merge sort is a divide and conquer algorithm that recursively divides the array into smaller subarrays, sorts them, and then merges them back together. Quicksort is also a divide and conquer algorithm that partitions the array into two different arrays, subarrays, around a pivot element and recursively sorts the subarrays. Each algorithm has its own approach and efficiency characteristics. Let's begin by implementing merge sort in C++. And this entire code will be in the description so that you can follow along in Replit or your IDE of choice. In this code snippet, we include the IO stream and vector header files. The vector header file provides a dynamic array-like container, and the IO stream header file enables input and output operations. We define two functions, merge and merge sort. The merge function merges two sorted subarrays into a single sorted subarray. The merge sort function implements the merge sort algorithm. Inside the merge function, we initialize the variables n1 and n2 to store the sizes of the two subarrays. We create two additional vectors, left array and right array, to store the elements of the subarrays. We then copy the elements from the original array into the subarrays. Next, we perform the merging process by comparing elements from both subarrays and placing them in the correct order in the original array. In the merge sort function, down here, we recursively divide the array into smaller subarrays until the base case is reached. We then merge the subarrays back together using the merge function. In the main function, we create a vector called data and initialize it with unsorted elements. To sort the vector using merge sort, we call the merge sort down here function, passing data, the left index 0, and the right index data size -1 as arguments. And finally, we print the sorted array using a range-based for loop and stdcout. Now let's move on to implementing quicksort in C++. In this code, we include the IO stream and vector headers as before. At the bottom is just return 0. We define two functions, partition and quicksort. The partition function partitions the array around a pivot element, placing smaller elements to the left and larger elements to the right. The quicksort function implements the quicksort algorithm. Inside the partition function, we choose the last element as the pivot. We initialize the variable I to keep track of the smaller element's index. We iterate through the array, and if we find an element smaller than the pivot, we increment I and swap the elements. Finally, we swap the pivot element with the element at index I+1 to place the pivot in its correct position. In the quicksort function, we recursively partition the array and sort the subarrays around the pivot element. In the main function, we create a vector called data and initialize it with unsorted elements. To sort the vector using quicksort, we call the quicksort function, passing data, the left index 0, and the right index data size -1 as arguments. Finally, we print the sorted array using a range-based for loop and stdcout.